Hello, this is Shravan. This is my video report for game 470, homework 1. This is the first code problem. This is the star pattern. And so basically you've got 4 outer triangles and then 1 square, which will take another 2 triangles to render. So a total of 6. Um, 8 points in all. So we just hard code them over here. Multiply by 8 over here. Uh, Then these are basically all the windings that we need. So we've got 6 triangles, so 6 sets of winding. And over here is the byte width. You've got size of word times 3 vertices for each triangle times a total of 6 triangles. And then finally, we just multiply by 6 over here as well. So finally, if I run this in now the solid mode, this is what's going to happen. There you go. Okay, so this is the second code problem, the n-sided polygon. As 15, this is our constant. Since we have to distribute everything around a circle, we have a radius of 0.5. Now most of the code is pretty much the same, but we just have two major areas where we have to parameterize. The first is creating the vertex buffer. So to do that, what we do is we have a small angle theta, which is basically 2 pi over the number of points that we have, and we basically this for loop over here distributes the vertices across the circle in increments of theta. Uh, for the index buffer now, the number of triangles that we'll need for n greater than equal to 3 is always going to be n minus 2. So the total number of indices is going to be that number times 3. And once again, this for loop, what it does is the sort of winding pattern that we're following is basically the 0 is the first point, so 0 1 2, then 0 2 3, 0 3 4, and so on. So that's what this for loop does. And other than that, everything else is parameterized, the byte width, and even in draw scene, take of it, let's do 7, and let's actually test it in solid mode. So there you go, that's the second code problem. Okay, so now we're in the triangle demo code. So this is what's going on for this first problem over here. The thing is that we're working in NDC, and for DirectX, NDC, the Z value just goes from 0 to 1. So specifying anything greater than 1 is going to, push that point beyond the far clip plane of the camera, and so there's going to be some clipping. This is why there's this top point over here gets clipped off, and this is why the top point and the right point over the bottom right point over here get clipped off. And obviously if you view this in solid mode, you get to see those particular shapes. Right, so working with top left, so this is basically, it specifies an origin with respect to which everything else is rendered. So we shifted it from 0 0 to 100 300, so there's an origin shift, which is why the image now appears here. If I change this and I make it 30, the image is going to come back up. So it's just basically it acts as an origin. Now, why is it useful to render to something else other than the window? For like so many reasons. We could, as discussed in class, we can take a picture of the user, so you render to a different buffer. In racing games, rear view mirrors, mini maps in so many games, GTA, Call of Duty, so much. Maybe you want to show a top view, maybe you want to do a picture in picture like this. So there's like a ton of applications for that. Okay, so data formats. We use data formats because we're interfacing with the GPU. So we send raw bytes to the GPU. So along with that, we need to pass in these data formats so that the GPU can make sense of the data that we are passing in. Now, unorm and uint. Uint is basically an unsigned integer, so accepts positive integers. Unorm is an unsigned normalized integer, so it accepts values in the range of 0 to 1. Sint is a signed integer, so allows for negative integers as well. Okay, so for these particular formats, the unorm format is used to specify color information for the back buffer. It's broken down into 4 components, so you can specify the RGB values, 8 bits each. It makes sense because the monitors generally don't support more than 24-bit color, and of course the alpha isn't outputted, so this format in particular is a very good choice. Finally, the R16 unsigned int format, we use this along with our index buffer. So again, our index buffer here is of type word, which is an unsigned short. So unsigned 16 bits, which is why we have unsigned 16 bits over here. And what does it have to do with red? Well, it's also something that can be used to specify the value of the red channel in 16 bits instead of, say, conventionally 8. So I think that's it. Thank you so much for watching, and until next time. Bye.